Hello, my name is Christopher Mercado.
I'm Jason Young.
I'm Madison Whitehead.
And I'm Osmani Perez, and this is Chapter 3.
So the first thing we want to get into is 3.1. So I'm going to ask the audience, what does an engineer do? Can anybody just throw out some ideas?
They design
Okay.
and they build stuff.
Build stuff. All right, so yeah, I guess you could say they design things, as in they could design a bridge, or they could design the tallest building in the world, or even a spaceship that carries people out to space, even maybe to Mars. So the key thing that engineers do is pretty much design devices, systems, or processes to help humans, to help us in our every day-to-day life. So what is engineering design? Well, a definition of engineering design is a systematic process by which solutions to the needs of humankind are obtained. So that's just, I mean, when they build things, they get the final solutions, and they, have the designs for us to use in our every day-to-day life. Engineers and technology. So this is technology is a big part in engineering now and today, because there's just so much technological advances that we use. So engineers are very empowered with the technical expertise to develop new and improved products and systems, but they always must be aware of the impact the actions will make on society and the environment. And over here is just a little diagram of how the engineering design process works. So I had the pleasure of doing a short story about this MD. His name is Nick Moore. So he has a BS in mechanical engineering and an MD, and he just obtained it from both Ohio. I think Ohio State University is where he went to college. And right now he is currently a resident physician in emergency medicine, as right now is when this book I'm sure was released. And he is caring for patients in 2 trauma centers and a helicopter transport in Indiana, Indianapolis. After residency, he looks for he's planning on looking for a faculty appointment at the university, or pursue further training in aerospace medicine offered by the Johnson Space Center, which is in the University of Texas in Austin. So the Johnson Space Center, he's actually already spent time working there and working with flight surgeons, and which, in his own words, he found to be very incredible. Dr. Moore was involved in many student activities, giving him knowledge on how to solve problems and make decisions without knowing the right answer, and to succeed and fail when the percentage of failure was very high. And as a student, he had no idea how many doors that this engineering degree could offer him, and would open up how many doors that he could get in a job. But in his advice to other students after he's completed his college career, he said, the important part is to have dreams and follow them wholeheartedly. If we do that, we will solve very interesting problems in our lives. And section 3.2, which is the design process, starts off with design, which is a very simple definition. It is a structured problem-solving activity. They said design is also not linear, which meant that you don't usually achieve the best solution by going from one step to another. As you saw in the picture before, even this picture at the bottom of the page, that you start off with the design and you just keep going through it and you evaluate it, and if the evaluation doesn't go right, you have to start all the way back to the beginning and keep going until you find your final product. So step 1 of the design process was figuring out how to set up the problem in the most efficient way for, everybody that can communicate, because engineering process and engineering design isn't just one set of engineers. You have the mechanical engineers. If that goes on to the biomedical engineers, it's passed on all throughout. So step 2 is also gain on possible information you can about the project. Step 3 is blueprint the product with all the desirable solutions, such as reliability, easiness to operate, acceptable costs, and how durable it is. Step 4, this step includes all the brainstorming on how prototypes and how they should look like. This step also includes a lot of computer modeling and analysis. And the final step, which was step 5, involves the most time, which is pretty much just design evaluation and making sure the product is completely finished and ready to give out to the public. So after this, I'm going to hand it off to Jason Yama.
Alright, so section 3.3 is the designer and the customer. So when the customer goes to the designer, they need to work together at all times. Because if the designer changes something in the product and the customer doesn't like it, they can change it back. And if they need to modify requirements such as meeting the deadline or money cost, they can do that. And there's actually a model called the Cano model, as you can see right here. It has 3 parts to it: the basic, performance related, and exciting. The horizontal axis is the degree of achievement, and the vertical is the satisfaction of the people. Right here, this line right here would be the basic. So that would be like the customer knows what he wants and he knows that people can do it. The performance related would be the line in the middle, and that's what they're aiming for at all times. And exciting is rarely met. It's called the lighters here, but it's rarely met because they. An example of that would be like asking the designer to program something, like for example a barbecue grill, to go at a certain amount of temperature each day at the same time. Alright, so section 3.4, the nature of engineering designers. So in the 20th century, people thought of engineering designers as creative people with a broad spectrum of knowledge. And in the 1950s, Benjamin Bloom actually built a model called the Bloom's taxonomy, and it starts from bottom with knowledge, comprehension, application, analysis, synthesis, and evaluation. And the higher you go, the more complex it gets. So in basic words, knowledge would be remembering, comprehension would be understanding, application would be applying, analysis would be analyzing, synthesis evaluating, and evaluation as creating. So section 3.5, it was a really short paragraph, and it just talked about how you can apply the engineering design to your education, and it tells you that it's very flexible, and it's a conceptual design, and you can apply it whenever you get your bachelor's. You'll have enough knowledge to make the right decisions, and so I pass it down to Madison.
Thank you. Okay, so me and Osmani will be talking about 3.6, which in basis talks about design opportunities and challenges that engineers will face in the future. So a couple problems that the book talked about that engineers will be talking about and we'll have to figure out solutions to are going to be making solar power just a little bit more cheaper and figuring out how to provide clear and safe water for our communities. So we all know solar panels aren't cheap. If they were, most of us would use them now today. And they typically cost about 7 to 9 per watt, and that adds up rather fast. And so along with that being a problem and making that expensive, clean water becomes an issue. Because the cost of panels is so high, it forces us to use fossil fuels, which causes pollution, therefore making some drinking water unsafe to consume. So energy was one of the topics, and as we said, section 3 is about future challenges engineers will face. This includes energy, and energy has always been a problem. Engineers will soon have to utilize their knowledge to produce a more proactive source of energy to ensure that pollution and global warming will not be a problem in the future. And so, therefore, engineers now must use as little unsafe energy as possible, and until they become a better source. So, environment was another topic, and as our need for energy grows, the harm done to our environment also does. So, design aspects have come into play to help us reduce the harm done. For example, hydroelectric generating stations produce electricity with the use of water. And so more energy becomes more problems. So the more we can utilize other things to make energy, the better off we are. So thus, engineers must be environmentally conscious in everything we do. So I'll pass this on to Osman.
Thank you. And now, we talk about infrastructure. What is infrastructure? Well, the definition is the basic physical and organizational structures and facilities, for example, buildings, roads, power supplies, needed for the operation of a society or enterprise. So, as a society, we use all of these things, and it's necessary for our lives. Some examples, 30 commercial jets, for example. We've been using them for many years, 35 to 40 years old. And we need to use the programs that we have to ensure that they're safe after 40 to 35 years, That's a long time, and they could be falling apart. But it would be too expensive to create new ones. So they have to balance it out, make new ones, but also keep the ones that we are using good enough to be able to use. And also interstate highways, 50 years old, same thing. They could be dangerous, but again, it could be, it's really expensive to, make new ones. They have to repair it so then they can still use it. And also municipal water, that's basically, water in the city, that you use, everyone uses billions of dollars to repair it and to make upgrades. So protecting our infrastructure. So public work facilities, so everything that's included in the infrastructure, it's worth $2 trillion. And so what we need are engineers to be innovative, to be creative in order to solve the problems so the infrastructure doesn't, deteriorate to where we can't even use them anymore. So engineers would create new ways to reuse what we already have, to make things cheaper and all that. So an example would be recycled asphalt pavement. So, in the road, they actually came up with stronger pavement, for asphalt when they recycled it. And engineering is a big part of that. Engineering research is a big part of making sure that our infrastructure doesn't deteriorate and that we can reuse it. And next one. A competitive edge in the workplace. So we use products from other countries, of course. So whenever we make things, right, we need to make sure that people from other countries, from other nations can use it and it's accepted in their cultures and environments. And in the international industry, of course, there's a lot of competition. Other nations are creating things all the time, so we need to keep up. And the goal is profit, of course. So what we need to do is find the best product that is the cheapest to create and it's the fastest to create, all at the same time. And so engineers are the ones who come up with these products, and they are the future of the industrial sector. Thank you.
So is there any questions about this chapter? Nope. All right, well, thank you for watching. This was chapter 3. We hope you learned a lot from it.